Hi students, today's class is Alkanes preparation second part. In last class up to Woods reaction, fitting reaction, Woods fitting reaction, up to that covered. Next one is preparation of alkanes from Grignard reagent. And another one is what you call decarboxylation by heating with soda lime. And from electrolysis of sodium salt of carboxylic acids. Now, first one, from carboxylic acids. Next preparation method is from carboxylic acids or sodium or potassium salt of sodium or potassium salt of carboxylic acid, aqueous concentrated solution. Aqueous means in water, concentrated, less quantity of water. So when aqueous concentrated sodium or potassium salt of carboxylic acid is subjected to electrolysis, alkane is formed. This reaction is called coal-base electrolysis. Coal-base electrolysis. Now, see here. How do you prepare alkanes by coal-base electrolysis? See, this is CH3COOH. What is its name? Acetic acid. Acetic acid. Acetic acid. For example, CH3COO. It splits into CH3COO minus and H plus. Instead of H plus, if you add Na plus, this becomes CH3COO Na. This is sodium salt of acetic acid or sodium acetate. Sodium acetate. Okay, sodium acetate. Now, here aqueous solution, concentrated. Aqueous solution of sodium acetate subjected to electrolysis. Electrolysis means this salt solution is taken into a beaker and place two electrodes. One is anode and another one is cathode. When electricity is passed through these electrodes into the solution, what happens? This salt CH3COONA, sodium salt of acetic acid, sodium salt, 2 moles CH3COONA plus water, aqueous solution, kada? That is why it contains water, H2O. Electrolysis, subjected to electrolysis. When electricity is passed through that solution, it converted into like this. H2, CO2, CO2, CH3, CH3 and CO2, carbon dioxide, 2 moles of carbon dioxide, 2 CO2, here 1 CO2, here 1 CO2 and NaOH plus 2 NaOH plus H2, HH converted into H2. Okay, so like that ethane is formed. Ethane. Okay. So here ethane and carbon dioxide are formed at one electrode and NaOH and H2 are formed at another electrode. So this is about what you call coal-base electrolysis. What is coal-base electrolysis? Coal-base electrolysis means when aqueous concentrated solution of sodium or potassium salt is subjected to electrolysis. As a result, alkanes are formed. Here, if acetic acid is taken, ethane is formed. Suppose compound CH3, CH2, COONA is taken. Which compound is formed? Another molecule. Two molecules join together and forms like this. Plus HOH, water gives rise to CO2, CO2, NaOH, NaOH, H2. Okay. Again, this CH3, CH2 attached with this CH2 and CH3, butane is formed. This is butane. Okay, like that. Depending upon the salt of carboxylic acid, here compounds are formed. This is sodium acetate, this is sodium propanoate. This is sodium propanoate. Compound is sodium propanoate. Sodium propanoate. Okay, like that. This is called coal-based electrolysis. Now, look at the board. Here RCONA. R generalized చేసి రాశాం. R. R means methyl, CH3, or ethyl, C2H5, so on. Any alkyl group. R indicates. Okay. That sodium salt of carboxylic acid on electrolysis forms anode. Alkane and carbon dioxide are formed at anode. Hydrogen and NaOH are formed at cathode. Okay, like that. See here, in this reaction, which are formed. In this reaction, sodium hydroxide is formed. Sodium hydroxide. As the reaction goes on, concentration of NaOH increases. NaOH means, is it acid or base? NaOH is a base. As a result, pH value, what happens gradually as the NaOH base concentration increases? pH value, what happens? pH value also increases. Okay. So, as the reaction goes on, pH of the solution increases in the vessel. Okay. And here, CO2 and alkane are obtained at anode. And H2 and NaOH are obtained at cathode. Okay, so that is about coal-based electrolysis. Okay, now next one. Soda lime decarboxylation. Next preparation method, soda lime decarboxylation. Soda lime. What is soda lime? Soda lime means soda lime. Soda lime. Soda lime means a mixture of NaOH and CaO is called soda lime. A mixture of NaOH and CaO is called soda lime. What is the use of soda lime? Soda lime is used for decarboxylation. Decarboxylation. Used for decarboxylation. Okay. So, it removes carbon dioxide from the salts. Removes carbon dioxide. See here, for example, CH3COONA. What is its name? Sodium acetate. Indaga తీసుకున్నది. Sodium acetate. When sodium acetate is heated with soda lime. Soda lime means NaOH and CaO. Okay, NaOH only involved in bond. As a result, see this H attached to this CH3 and forms CH4 plus Na2CO3, sodium carbonate. This is Na2CO3, sodium carbonate is formed. Okay, sodium carbonate. Here this is methane. See here, one carbon converted into sodium carbonate. Here CO2 escapes out in the form of Na2CO3. సో ఇక్కడ ఎన్ని కార్బన్స్ అయితే తీసుకున్నావో దానికంటే ఒక కార్బన్ తక్కువ ఉన్నది ఫామ్ అవుతుంది. ఓకే, ది हियर टोटल नंबर ऑफ कार्बन्स में से एक निकाल के उसमें से कितने कार्बन्स होते हैं वो कार्बन वाला आल्केन फॉर्म होगा. 2 कार्बन एटम्स है यहाँ पर, एक कार्बन वाला फॉर्म होगा बिकॉज वन ऑफ द कार्बन एटम एस्केप्स आउट इन द फॉर्म ऑफ कार्बन डाइऑक्साइड CO2. ओके, Na2CO3. సో దిస్ ఈజ్ స్టెప్ డౌన్ రియాక్షన్. ఒక కార్బన్ తగ్గుతుంది కదా, కాబట్టి దిస్ ఈజ్ అన్ ఎగ్జాంపుల్ ఆఫ్ స్టెప్ డౌన్. स्टेप डाउन रिएक्शन. स्टेप डाउन रिएक्शन मीन्स जो भी कार्बन एटम्स है रिएक्टेंट में उसमें से एक कार्बन कमती वाला फॉर्म होता है, उसे बोलता है कि स्टेप डाउन रिएक्शन. ओके, सो लाइक दैट. दिस इज सोडा लाइम decarboxylation. NaOH plus CaO, a mixture of NaOH and CaO, 3:1 ratio. Okay, that is soda lime. Okay, next one. In this reaction, which are formed means carbene ion intermediates are formed. Carbene ion, C minus. Carbene ion intermediates are formed. And rate of decarboxylation is proportional to stability of carbene ion. Rate of decarboxylation, stability of carbene ion. Suppose see here, CH3, CH3, CH3. Okay, carbene ion, negatively charged. Here, CH3, CH3, H, carbene ion. And another one is like this. CH3, H, carbene ion. And another one, H, carbene ion. Which is more stable? This is a tertiary carbene ion. This is secondary carbene ion. This is primary carbene ion. This is methyl carbene ion. Methyl carbene ion. Which is more stable? Yes, methyl carbene ion is more stable. So, methyl carbene ion. So, suppose here CH3 COONA is present here. COONA, CH3 COONA. So, यहाँ पर क्या फॉर्म होता है? C माइनस फॉर्म होता है. ये methyl carbene ion है. ये more stable. So, such type of compound involved easily. Rate of decarboxylation. ये COONA निकल जाता है. इसमें से జల్దీ నికల్ जाता है. దేని నుంచి తొందరగా వెళ్ళిపోతుంది. సో ఇది బయటకు వెళ్ళిపోతే ఇక్కడ మిథైల్ కార్బన్ అయాన్ ఫామ్ అవుతుంది. ఇది మోర్ स्टेबल కాబట్టి దాని నుంచి బయటకు వెళ్ళిపోతుంది. मिथाइल कार्बन आयन मोर स्टेबल है, इसीलिए इसके पास जो भी है COONA वो जल्दी से निकल जाता है. इसमें भी है COONA, ये जल्दी से नहीं निकलेगा क्योंकि इसमें इट इज कंपैरेटिवली लेस स्टेबल. ये और भी लेस स्टेबल, ये वेरी लेस स्टेबल. सो मिथाइल कार्बन आयन जिसमें फॉर्म होता है COONA निकलने के बाद वो कंपाउंड से आल्केन जल्दी से फॉर्म होता है, तोंदरगा फॉर्म होता है. सो रेट ऑफ decarboxylation is directly proportional to stability of carbon ion. Okay, right. See, product contains one carbon atom less than the reactant. That is why this reaction is used for stepping down reaction. ఇందాక చెప్పాను కదా, ఒక కార్బన్ తగ్గుతుంది కాబట్టి స్టెప్పింగ్ డౌన్. ఓకే, వాట్ ఈస్ ది యూజ్ ఆఫ్ CaO in this process? CaO is dehydrating agent. Note down, dehydrating agent. CaO is a dehydrating agent. यहाँ पर NaOH यूज करते हैं ना ये रिएक्शन में. NaOH is a hygroscopic substance. Hygroscopic substance means which absorbs water molecules when exposed to air. Which absorbs water molecules when exposed to air. When exposed to air or atmosphere. एटमॉस्फेयर में रखने से वो वाटर को एब्जॉर्ब करके एटमॉस्फेयर से लिक्विड बन जाता है. लिक्विड. सच टाइप ऑफ सब्सटेंसेस आर कॉल्ड हाइग्रोस्कोपिक सब्सटेंस. इसको ड्राई रखने के लिए जो भी वाटर एब्जॉर्ब करता है NaOH उससे ये ले लेता है CaO. इसीलिए इसे ड्राई रखता है NaOH को. ड्राई NaOH चाहिए ए रिएक्शन में. सो दैट इज वाई CaO is used. It is a dehydrating agent. వాటర్ को నికాల్ देता है. అర్థమైందా? NaOH పొడిగా ఉండాలి, వాటర్ ఉండకూడదు. NaOH వాటర్ తీసేసుకుంటూ ఉంటుంది, అబ్జార్బ్ చేసుకుంటుంది. హైగ్రోస్కోపిక్ అంటారు అలాంటి వాటిని. కాబట్టి దాని నుంచి వాటర్ తీసేసుకోవడానికి CaOని యూజ్ చేస్తారు. జస్ట్ CaO ఉంటుంది, అది రియాక్షన్లో ఇన్వాల్వ్ కాదు. రియాక్షన్లో ఇన్వాల్వ్ అయ్యేది NaOH. ఓకే, లైక్ దట్. సో वो पूछेगा उसमें व्हाट इज द यूज ऑफ CaO इन सोडा लाइम? To absorb water molecules. Okay, to get dry NaOH. CaO is used to keep NaOH dry because it is quite hygroscopic in nature. Okay, right. Okay, now that is not necessary. Beta keto. Next, from Grignard reagent. Okay, from Grignard reagent. From Grignard reagent. Grignard reagent. Okay, what is Grignard reagent? Do you know? Grignard reagent. Grignard reagent means very, very important. RMGX. RMGX is called Grignard reagent. Grignard reagent. What is R here? Here R means alkyl group. It is alkyl group. And Mg means magnesium metal. Magnesium. Okay. And what is X? Halogen. Any halogen. Fluorine, chlorine, bromine, iodine. Okay. Halogen. This is called Grignard reagent, RMGX. So how do you prepare that Grignard reagent? Grignard reagent can be prepared by preparation of Grignard reagent. Grignard reagent. How do you prepare? Alkyl halide, RX, when treated with magnesium metal in the presence of dry ether. As a result, what happens? RMGX is formed. RMGX. This is Grignard reagent. Okay, this is alkyl halide, RX, Alkyl halide, general formula. This is magnesium. When alkyl halide is treated with magnesium in the presence of dry ether, RMGX Grignard reagent is formed. ये Grignard reagent से alkane prepare करते हैं. Grignard reagent నుంచి alkane तैयार చేస్తాం మనం. Okay. Now see here. And another examples like this. Suppose here C2. C2 or CH3. CH3Cl, methyl chloride instead of RX, plus magnesium in the presence of dry ether. As a result, which is formed? CH3MgCl. What is its particular name? Methyl magnesium chloride. Methyl magnesium chloride. Means Grignard reagent is formed. Its common name is Grignard reagent. Okay. Grignard reagent. Now, another one. Suppose if you take here CH3, CH2, Br plus Mg, which is formed dry ether, in the presence of dry ether, CH3, CH2, Mg, Br. What is its name? Ethyl group, C2H5. So, ethyl magnesium bromide. Ethyl magnesium bromide is formed. Ethyl magnesium bromide. Okay, like that. Now, suppose if you take here another one, what is its name? What is its name? Chlorobenzene. Its name is chlorobenzene. Okay, treated with magnesium. Here also, this is also RX, like RX. RK plus में ring है. Okay, here which is formed here? Phenyl. This group is called phenyl magnesium chloride. Phenyl magnesium chloride. Phenyl magnesium chloride is formed. It is also Grignard reagent, RMGX. Okay, so those are all what you call Grignard reagents. All are Grignard reagents. So with the help of Grignard reagents, we can prepare alkanes. So how do you prepare alkane? Now look at the board. See, it can be prepared like this. Alkane can be prepared from Grignard reagent. For example, CH3MgCl, methyl magnesium chloride. Hydrolysis. Hydrolysis means treating with water. Treating with water. See here, it breaks down here, Grignard reagent, and H added here, OH added here. As a result, CH4, it becomes CH4 and it becomes MgOHCl. MgOHCl, because magnesium charge is 2 plus, OH minus, Cl minus. 2 negative charges, 2 positive charges here. Okay, like that. Okay, this is methane. Methane is prepared like this from Grignard reagent. Methyl magnesium chloride. This is methyl magnesium chloride. When methyl magnesium chloride is subjected to hydrolysis, this reaction is called hydrolysis. Okay. So एक कंपाउंड को दूसरा कंपाउंड से डिकंपोज करना, वाटर से डिकंपोज कर दिए, ఒక కాంపౌండ్ ని ఇంకో కాంపౌండ్ తో డికంపోజ్ చేయడం. ఓకే, ఇప్పుడు చూడు అనదర్ రియాక్షన్ విత్ సపోజ్ కాంపౌండ్ ఈజ్ లైక్ దిస్ CH3 CH2 MgBr plus D2O. D2O means deuterium oxide, heavy water, like H2O. D is heavy isotope of water, heavy isotope of hydrogen. Deuterium oxide or heavy water. What happens? Here D2O means like DOD, like HOH, D2O. Instead of D2O, you can write. Bond breaks down between alkyl group and magnesium. Okay. Now one D added here, one OD added here, like OH. As a result, compound is CH3 CH2D plus MgBr OD. Magnesium M like this. Instead of OH, here OD is present. Nothing but that is also hydrogen, heavy hydrogen. So this is the compound. CH3 CH2D means nothing but CH3, what you call CH3 CH3. Instead of D, another H రాసినట్లయితే ఇలా వస్తుంది. అంటే ethane, this is nothing but ethane, C2H6. ethane जैसा है एक हाइड्रोजन के प्लेस में D है. heavy ethane is formed. Heavy ethane is formed. Okay. Heavy ethane or deuteroethane. Deuterium ఉంది కాబట్టి deuteroethane. Deuteroethane is formed. Okay. Now suppose compound is like this. Grignard reagent, that is MgI, phenyl magnesium iodide or MgX, treated with water, HOH, hydrolysis. As a result, bond breaks down here, H and OH added at magnesium. As a result, which is formed? Compound H plus MgOHI is formed. Here magnesium valence is always 2 plus 2, OD minus Br minus. Here 2 plus, OH minus I minus. You neutralize the 2 negative charges. Like that. What is its name? This is nothing but benzene. Benzene is formed. H separate గా రాసాం అంతే. C6H6, that also. Okay. Like that. Suppose hydrolysis can be done with the help of ethyl alcohol also. Suppose compound is like this. CH3 CH2Br plus ethyl alcohol. Formula C2H5OH. This is Grignard reagent. Ethyl CH2Mg. Ethyl magnesium bromide. Ethyl magnesium bromide. When ethyl magnesium bromide is treated with ethyl alcohol, See here, it splits into like this. This is ethoxide ion, C2H5O minus. This H plus adds here. Here, C2H5O minus. As a result, compound is CH3CH3 plus MgOC2H5Br. This is ethane, nothing but. Means hydrolysis can be done with the help of, this is ethyl alcohol. Ethyl alcohol, like that. Okay. That is about preparation of Grignard reagent and preparation of alkanes from Grignard reagent. Okay. Is it clear now? So here, Rx when treated with magnesium, RMgX, Grignard reagent, CH3BrMg, CH3MgBr, methyl magnesium bromide, bromobenzene, magnesium, phenyl magnesium bromide. Okay. ఏదైనా రాసుకోవచ్చు. You can write any Bri, any halogen atom here. Okay. And then see, this is Grignard reagent. When phenyl magnesium bromide is treated with water, phenol, benzene is formed. Isn't it? This is benzene, first one. And phenyl magnesium bromide D2O instead of HD and MgODBr. Isn't it? Alage CH3MgBr plus C2H5OH. CH4, this is nothing but CH4 MgOH, MgBr and OC2H5. Okay. So like that. You can write different types of equations. Okay. So that is about preparation of alkanes. Here, this is nothing but benzene. This is also heavy benzene. D unte heavy benzene anu. Deuterobenzene. This is methane, CH4, like that. Okay. And last one, preparation from metal carbides. Hydrolysis of metal carbides. Aluminium carbide, formula Al4C3, aluminium carbide. See, I will explain here. Aluminium carbide. Aluminium carbide. What is the formula of aluminium carbide? Aluminium carbide formula is Al4C3. When treated with hydrolysis, H2O, water. As a result, aluminium oxide, Al2O3. Al2O3 plus CH4. CH4 are formed. Methane is prepared by hydrolysis of aluminium carbide. This is aluminium carbide. Aluminium carbide, water. Aluminium oxide and methane, gas is liberated. Like that, beryllium carbide, Be2C. Beryllium. Beryllium carbide. When beryllium carbide is treated with water, as a result, beryllium oxide, BeO, plus methane, CH4, are liberated. See here, aluminium and beryllium shows a diagonal relationship. Periodic table laws. Diagonal relationship. Do you know diagonal relationship? See here, what you call 1A group elements, lithium, sodium, beryllium, magnesium, boron, aluminium, carbon, silicon. These are 1A group, 2A group elements, 3A group elements, 4A group elements. This is what you call second period. Second period elements. These are third period elements. See here, the elements which are present in the same group exhibit similar properties. So lithium should resembles with sodium, but lithium is shows more resemblances with magnesium than sodium. Like that, beryllium also shows more resemblances with aluminium, like boron resembles with silicon. That is called diagonal relationship. Means the element which is present in second period resembles with the element present in third group of next higher group. Means 1A group element resembles with the 2A, 2A group element resembles with the 3A, 3A group element resembles with the 4th A group element. Next higher group, next period. Okay, like that. So that is why, see here, beryllium and aluminium shows similar properties. Both the carbides undergo hydrolysis and liberates methane. That is one resemblance, CH4. Okay, both oxides are BeO and Al2O3 are amphoteric oxides. Amphoteric oxides. Amphoteric oxides. Oxides are of how many types? Oxides are of how many types? 4 types. What are those 4 types? Number 1, acidic oxides. Number 2, basic oxides. Number 3, amphoteric oxides. Number 4, neutral oxides. Here, what you call beryllium and aluminium are amphoteric oxides. That is a different thing. Means both are amphoteric oxides, both carbides undergo hydrolysis and liberates methane gas. These are the resemblances between beryllium and aluminium. Okay, like that. So, methane can be prepared by hydrolysis of aluminium carbide and beryllium carbide. Okay, beryllium hydroxide. ఇక్కడ ఏం రాశాను నేను? బెరీలియం ఆక్సైడ్ రాసినట్టున్నాను. See, once again, beryllium aluminum hydroxide. See here, reaction is aluminium వెంటనే water తో react అయ్యి this oxide forms AlOH thrice. AlOH thrice రాసుకో. AlOH thrice, BeOH twice. హైడ్రాక్సైడ్స్ వచ్చేస్తాయి వెంటనే. ఓకే, aluminum hydroxide and beryllium hydroxide. So that is about preparations. And the next one is, right, very good, physical properties. Physical properties of alkanes. Now, solubility. First one, solubility. See, alkanes. First alkane is CH4. Second one, C2H6, C3H8, C4H10. Isn't it like that? All these alkanes are polar compounds or non-polar compounds? All are non-polar compounds. Non-polar compounds. Non-polar compounds are soluble in non-polar solvents. Non-polar solvents. Soluble in non-polar solvents. Non-polar solvents, example, non-polar solvents. Example, benzene, carbon tetrachloride, CCl4, kerosene, diesel, etc. So these are all non-polar compounds. So they are, alkanes are non-polar compounds. That is why they are soluble in non-polar solvents like benzene, carbon tetrachloride, etc. Okay, but polar compounds are soluble in polar solvents. Polar compounds. For example, NaCl is a polar compound. Na plus Cl minus. It is soluble in water. Water means H2O. Oxygen gets partial negative, hydrogen gets partial positive. In between this chlorine and hydrogen there is a attraction. As a result, bond breaks down. That is why sodium chloride is soluble in polar solvents like water. Okay. Next one, boiling points. Means here point is like dissolves like. Like dissolves. Like dissolves like means polar compounds are soluble in polar solvents. Okay. అలాగే non-polar compounds are soluble in non-polar solvents. That is called like dissolves like. Similar compounds soluble in one another. Okay. Next, boiling point. See, boiling point, what happens? Boiling point. Very important one. Look at the board. Boiling point. as the molecular weight increases, as the molecular weight increases, melting point and boiling point both increases. Here particularly boiling point also increases. Okay. Suppose here methane CH4, ethane C2H6, propane C3H8, butane C4H10, H10. So boiling point, what happens? Boiling point increases. Boiling point increases. Here low boiling point, here high boiling point, isn't it? As the molecular weight increases, boiling point also increases. Okay. Suppose compound is like this. Suppose what you call one compound is like this. CH3, CH2, 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 CH3. What is its name? How many carbon atoms are there? 5 carbon atoms. Cheppu. N-pentane. Its name is N-pentane. Okay, normal pentane. Suppose compound is like this. CH3, C, CH3, CH, CH2, CH3. What is its name? Yes, isopentane. Isopentane. Second last carbon contains methyl group. So it should be isopentane, common name. And another compound is like this. CH3, C, CH3, CH3, CH3. What is its name? Neopentane. Neopentane. See, all are pentanes. How many carbon atoms are there in all these compounds? 5 carbon atoms. 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5 carbon atoms. Okay. And the carbons and hydrogen atoms also same. So all these 3 compounds, 1, 2 and 3, contains same number of carbon atoms. How many carbon atoms? C5. H. Hydrogens. How many hydrogens? Cn H2n plus 2. 14. C5 H14. ఇది 2 10 11 12 12 C5 H12. C5 H12. Okay. మళ్ళీ రాద్దాం ఇక్కడ C5H12. C5H12. All have same number of carbon atoms, same number of hydrogen atoms. And which should have high boiling point? That is question here. All have same molecular weight. How much molecular weight? C5 at 5 into 12, 60. 12 into 1 hydrogen, 12. That is how much? 72. All have 72 molecular weight. So whose boiling point is more means as the number of branches increases, boiling point also, BP also increases or decreases. Sorry. Boiling point, what happens? Boiling point decreases. Boiling point decreases. ఏం చెప్పాను నేను? నెంబర్ ఆఫ్ బ్రాంచెస్ ఇంక్రీజెస్ అన్న. బ్రాంచెస్ ఇంక్రీజ్ అయితే బాయిలింగ్ పాయింట్ డిక్రీజెస్. మీన్స్ బాయిలింగ్ పాయింట్ ఈజ్ ప్రపోర్షనల్ టు 1 by నెంబర్ ఆఫ్ బ్రాంచెస్. Number of branches, isn't it? Boiling point is proportional to 1 by number of branches. See here it has a high boiling point, means which among these 3 which has highest boiling point? 1 is greater than 2 is greater than 3. BP order of the above compounds, boiling point. First compound means N-pentane is greater than, isopentane is greater than neopentane. Why? Branches kaadu. Here it has high boiling point. Why? First one has highest boiling point among these 3. Why? What is the reason? No branches? Okay. No branches అయితే ఏంటవుతుంది? Surface area increases. Surface area increases. As the surface area increases, attraction between the molecules increases. Suppose this is a long chain, this is another long chain. This is its surface area. This is its surface area. So greater the surface area, greater is the attraction between these 2 molecules. But here molecule is like this. Here another molecule. Here attraction is present between these two molecules like this. So here surface area is less. Here neopentane, this one. This is another neopentane. So attraction is present between here only, this much. We can break down easily. But here you have to break all these attractions. That is why its boiling point is more. Its boiling point is less. So as the number of branches decreases, surface area increases. As the number of branches decreases, surface area what happens? Surface area increases. So BP what happens? Increases. Boiling point increases. Okay. This is the reason. Okay. Now, so that is about boiling point. See, boiling point is proportional to molecular weight. If two different molecular weights are given, one is ethane and another one is propane. Propane has high boiling point because its molecular weight is more. If molecular weight is the same, lesser the number of branches, greater is the boiling point, greater is the surface area. Okay, like that. See, N-butane, this is N-butane, N-pentane, N-pentane and N-hexane. N-butane, less boiling point. N-pentane, more number of carbon atoms. Pent kada, 5. Here but, 4 carbon atoms, 5 carbon atoms, 6 hex. So, more high molecular weight, high boiling point. Okay, is it clear? Now here, N-pentane, isopentane, neopentane. Which has high boiling point means? N-pentane. More surface area here. More surface area. Here, less surface area. Okay? Now, next one. Now, chemical properties. So, chemical properties are very important here. Chemical properties. Chemical properties of alkanes. See, alkanes are saturated or unsaturated? Saturated compounds, because 4 valencies of carbon are satisfied with single bonds. Okay, saturated compounds. Saturated compounds gives which type of reactions? Last class lo cheppa, types of reactions in organic chemistry. Which reactions? Substitution reactions. These are called, these are saturated compounds. Reactions are of 4 types. What are those 4 types? Substitution reactions, addition reactions, elimination reactions and rearrangement reactions. So, which compounds give substitution reactions? Alkanes. Alkanes give substitution reactions. Addition reactions given by unsaturated carbon-carbon double bond or carbon-carbon triple bond. Elimination and rearrangement, different types of reactions. See here, saturated compound. So, what is the characteristic property of alkanes means? Substitution reactions. They give substitution reactions. Substitution. Suppose ఇది బాండ్లో ఇన్వాల్వ్ అవ్వాలంటే ఆల్రెడీ ఇక్కడ అటాచ్ అయి ఉన్న దాంట్లో ఏదో ఒకటి సపరేట్ అవ్వాలి. సపోజ్ టేక్ మీథేన్. ఇది సమ్ క్లోరిన్తో రియాక్ట్ అవ్వాలి అంటే ఇట్ కెన్ నాట్ ఫార్మ్ అనదర్ బాండ్ విత్ క్లోరిన్. 5th బాండ్ ఫామ్ చేయలేదు కదా. సో ఇది క్లోరిన్తో రియాక్ట్ అవ్వాలంటే ఒకటి బయటికి పోవాలి, అప్పుడు క్లోరిన్ రావాలి. బికాస్ సాచురేటెడ్. అన్సాచురేషన్ లేదు. ఇఫ్ అన్సాచురేషన్ ఈస్ ప్రెజెంట్, వాట్ హ్యాపెన్స్? బాండ్ బ్రేక్స్ డౌన్. ఇటువైపు ఒక క్లోరిన్, అటు ఒకటి యాడ్ అయ్యి ఉండేది, ఎడిషన్ రియాక్షన్ అయ్యి ఉండేది. హియర్ నో వాట్ యు కాల్ అన్సాచురేషన్. సో బాండ్లో ఇన్వాల్వ్ అవ్వాలి అంటే షుడ్ లూజ్ one of the atoms which are attached with carbon. Okay, like that. So now see here, substitution reactions in alkanes. Now see here, RH means alkane. RH alkane reacts with, first one, substitution reaction with halogenation. What is halogenation? Last class lo konni meanings cheppanu. Halogenation means addition of halogens, fluorine, chlorine, bromine, iodine. Chlorination means addition of chlorine. Bromination means addition of bromine, isn't it? And what you call decarboxylation. రిమూవల్ ఆఫ్ కార్బన్ డైఆక్సైడ్. సోడా లైమ్తో చేస్తాం. వాట్ ఈస్ ది యూజ్ ఆఫ్ సోడా లైమ్ ఇన్ ఆర్గానిక్ కెమిస్ట్రీ మీన్స్ ఫర్ డీకార్బాక్సిలేషన్, టు రిమూవ్ కార్బన్ డైఆక్సైడ్ ఫ్రమ్ ది కాంపౌండ్. ఓకే, సో అలాగే హైడ్రేషన్. వాట్ ఈస్ హైడ్రేషన్? ఎడిషన్ ఆఫ్ వాటర్ ఈస్ కాల్డ్ హైడ్రేషన్. డీహైడ్రేషన్, రిమూవల్ ఆఫ్ వాటర్ ఈస్ కాల్డ్ డీహైడ్రేషన్ రియాక్షన్. సో లైక్ దట్ కొన్ని టెర్మినాలజీ ఉంటుంది దీంట్లో. సో హియర్ దిస్ is RH means alkane, treated with X2 means halogen, means chlorine, bromine, Cl2, Br2, I2, etc. So this reaction is carried out in the presence of diffused sunlight anna, HNU anna, UV light anna, and 573 to 773 kelvins are heating. Any one of these arrow mark మీద ఉన్నట్లయితే homolytic fission. Fission చెప్పాను కదా, homolytic fission, heterolytic fission. Homolytic fission ఎప్పుడు ఫామ్ అవుతుంది? When will homolytic fission takes place? When homolytic fission takes place in non-polar compounds. Non-polar compounds. Here it is a non-polar bond, no polarity. So here carbon hydrogen electronegativity is almost equal to the electronegativity of hydrogen. Carbon electronegativity how much? 2.5. Hydrogen electronegativity how much? 2.1. Almost same. So electron pair is present at the center of the two atoms. So when it is heated, what happens? Exactly at the center of the bond. Bond breaks down. As a result, free radicals are formed. This is non-polar bond. Non-polar compounds undergo homolytic fission or heterolytic fission? Homolytic fission. As a result, free radicals are formed. These are called free radicals, isn't it? See here, in the presence of heating or in the presence of sunlight. Already explained that point in previous class. Okay, now see here, RH means alkane, treated with hydrogen, treated with halogen. In the presence of diffused sunlight anna, HNU anna, UV anna, temperature anna, delta mark anna, all are same. As a result, what happens? One of the H escapes out and another X added at that place. As a result, alkyl halide is formed. Alkyl halide is formed. And this removed H and X atom combine together and forms HX. Okay. Now see here, CH4 plus Cl2 gives rise to one of the hydrogen. See here, compound is like this, CH4 plus Cl2 in the presence of HNU. One H, or you can write Cl. One H combined with Cl and escapes out in the form of HCl. This Cl added to that carbon atom. As a result, CH3Cl is formed. Okay, that is substitution. Instead of this hydrogen, one chlorine is added. Substitution reaction. Okay. Now in alkanes, substitution of halogens takes place in 3 steps. What are those 3 steps? What are those 3 steps? Halogenation. Halogenation means addition of halogen kada. Halogenation in alkanes. Takes place in how many steps? 3 steps. What are those 3 steps? First one is chain initiation. Starting. Chain initiation. Second one, chain propagation. Chain propagation. Third one, chain termination. Yes, chain termination. See here, halogenation of alkanes is dash reaction mechanism. Free radical mechanism. Free radical. Why? Here CH bond undi kada, correct ga ikkada break avutundi. ఫ్రీ రాడికల్ ఫామ్ అవుతుంది, సి ఫ్రీ రాడికల్. అక్కడ క్లోరిన్ ఫ్రీ రాడికల్ వచ్చి సికి సిఎల్కి మధ్య బాండ్ ఫామ్ అవుతుంది. ये फ्री रेडिकल में जो भी इलेक्ट्रॉन्स है वो शेयर करके CCl बॉन्ड फॉर्म फ्री रेडिकल्स. So free radical mechanism. So halogenation is carried out. Halogenation carried out by free radical mechanism. Free radical mechanism. Not carbon ion, not carbocation. Free radical mechanism. Okay, now see here, first one is, what is first step? Chain initiation step. Chain initiation step. See here, chain initiation step mechanism. Cl here homolytic fission takes place. Generally homolytic fission takes place in the presence of sunlight or heating. But homolytic fission in what you call polar compounds takes place in the presence of sunlight, in the presence of catalyst. Catalyst చెప్పాను ఆల్రెడీ లాస్ట్ క్లాస్లో. ఓకే, ఇప్పుడు సపోజ్ ఇది ఉందనుకో, BR అని ఉందనుకో, ఇది పోలార్ కోవలెంట్ బాండ్. ఇది బ్రేక్ అవ్వాలి అంటే, హోమోలైటిక్ ఫిజన్ జరగాలి అంటే catalyst వాడాలి. AlCl3 catalyst should be used. So polar covalent bond can be can undergo homolytic fission in the presence of catalyst. But non-polar covalent bond undergoes homolytic fission in the presence of sunlight or heating. Okay, so here sunlight is used means that is non-polar covalent bond. Here non-polar covalent bond. That is why it dissociates into free radicals in the presence of sunlight and forms two free radicals, chlorine free radicals. Okay. Now step 2, chain propagation. This free radical, see, CH3 and H. Okay. Here ఇక్కడ ప్రతి దాంట్లో 2 electrons, ఇక్కడ 2 electrons, here also 2 electrons, here 2, here 2, here also 2. Okay, now see here, Cl free radical when come closer to this methane, here homolytic fission takes place and this Cl free radical and H free radical combine together and forms HCl, forms a bond, and CH3 free radical is formed. CH3 free radical. Okay, so this is what you call chain propagation reaction. Chain propagation. First step. ఇప్పుడు second step లో again chlorine undergoes homolytic fission. One chlorine attached to that, అంటే CH3 is like this free radical. Here chlorine molecule. Here it undergoes free homolytic fission. As a result, CH, and this free radical attached with chlorine free radical and forms a bond and liberates Cl free radical. Cl free radical. Understand or not that reaction? Okay, like that. That is called chain propagation. ఒక హైడ్రోజన్ తర్వాత ఇంకో హైడ్రోజన్ యాడ్ అవుతూ ఉంటుంది. 4 steps లో 4 hydrogens replaced with 4 chlorine atoms. Because methane contains 4 hydrogen atoms. 4 steps takes place. Okay, that is chain propagation process. Chain termination. Chain ఆగిపోవాలి, stops by combining 2 free radicals and forms Cl2. Or CH3 free radical combines with another CH3 free radical and forms C2H6. And then here what you call, that is chain termination reaction, Cl2. And here another one is CH3 free radical plus Cl free radical gives rise to CH3Cl. So no free radicals are liberated here, isn't it? no free radicals in these 3 steps. So chain termination takes place. Ika reaction jaragadu. Okay. So like that. 3 steps mechanism. Halogenation of alkanes by free radical mechanism. Okay. Now see here. Suppose, once again, listen to me here. Suppose compound is like this. CH4 plus Cl2 in the presence of sunlight. As a result, CH3Cl minus HCl. Isn't it? ఒక H ఒక Cl కలిసి HCl. ఆ H ప్లస్ లో Cl వచ్చింది. And again reacts with Cl2 in the presence of sunlight. H ni. Again one H and Cl combine together and forms HCl. As a result, CH2Cl2. Again it reacts with another mole of chlorine in the presence of sunlight, and again minus HCl. CHCl3. Again it reacts with Cl2 plus Cl2. Okay. H in the presence of H minus HCl. Finally CCl4. Okay. What is this compound? Methyl chloride. In first step, which is formed? Methyl chloride or chloromethane. Its name is chloromethane. And second compound, methylene chloride. Methylene chloride, or methylene chloride is also called as dichloromethane. Dichloromethane is formed. And the third step, which is formed, what is its name? Here, CCl4 here. What is its name? Chloroform. CHCl3 or trichloromethane. Trichloromethane. And what is its name? Carbon tetrachloride. Carbon tetrachloride or tetrachloromethane. Tetrachloromethane is formed. Tetrachloromethane. Okay. See here, question is like this now. Here 1 mole of methane reacts with how many moles of chlorine? 4 moles of chlorine. 1 mole of methane. Here 1 mole Cl2. Here another mole. Here another mole. Here another mole. Okay. Cl2 plus Cl2 plus Cl2. Okay. Like that. Total how many moles are there? Means how many hydrogen atoms are there? 4 hydrogens. To remove 4 hydrogens, how many moles of chlorine is required? 4 moles of chlorine is required. Finally, carbon tetrachloride is formed. My question is, if 1 mole of CH4 is treated with 2 moles of chlorine, the product is dash. Which compound is formed? 1 mole of methane reacts with 2 moles. ఇదిగో ఇక్కడ 1 mole అయింది, ఇక్కడ 1 mole అయింది. Product is dash. CH2Cl2. CH2Cl2. Dichloromethane or methylene chloride is formed. Or to produce chloroform from 1 mole of methane, how many moles of chlorine is required? 3 moles of chlorine is required. Okay. So in this process, mixed compounds are formed, isn't it? Ante methane, when treated with chlorine, different compounds are formed. Monochloro, dichloro, trichloro, tetrachloro compounds are formed. To avoid all those things, to avoid polyhalogenation, excess methane should be taken. CH4 plus Cl2 gives rise to CH3Cl. If excess methane, less quantity of chlorine. ఇక్కడతో ఆగిపోవాలనుకో, మోనోక్లోరో మీథేన్ కావాలి, నాకు మిథైల్ క్లోరైడ్ కావాలి. ఇఫ్ యూ నీడ్ మిథైల్ క్లోరైడ్, You should take more methane and less quantity of chlorine. If more quantity of chlorine is present, that again reacts with that product. So first step to stop అయిపోవాలి అంటే methyl chloride తో you have to take excess of methane, less amount of chlorine. If CH4 plus Cl2 excess, so which compounds are formed? Dichloro, trichloro, tetrachloro కూడా ఫామ్ అయిపోతుంది. క్లోరిన్ ఎక్కువ ఉంది కాబట్టి. Understand or not? Point. Okay, like that. Okay, so that is about see here. Right? So ఇప్పటివరకు ఏం చెప్పాను నేను? రైట్, ఏది ఇదిగో ఇది దీనికోసం CH4 ఎక్కడ ఉన్నాం? ఇక్కడ దాకా వచ్చేసాం. ఇదిగో మీథేన్ ట్రీటెడ్ విత్ క్లోరిన్, మిథైల్ క్లోరైడ్, ఫైనల్లీ ఎక్సెస్ తీసుకుంటే క్లోరిన్ టెట్రాక్లోరోమీథేన్, ఎక్సెస్ మీథేన్ తీసుకుంటే మోనోక్లోరోమీథేన్ హియర్. ఓకే, అండ్ మీథేన్ విత్ క్లోరిన్ 4 different steps already given that equation. First one methyl chloride, methylene chloride, chloroform, carbon tetrachloride. Okay, like that 4 different steps. And see here what you call here, which halogenation kada, which halogen is more reactive towards halogenation of alkanes? Fluorine is more reactive than chlorine, is more reactive than bromine, is more reactive than iodine. Reactivity order of halogens is important bit. This reaction is carried out in the presence of intermediate carbon free radicals or carbocation or carbanion. Carbon free radicals. So in this reaction, intermediate is carbon free radical. Intermediate is carbon free radical. Okay, so that's enough. And then see, rate of 1 point. Rate of halogenation is proportional to stability of free radical. No doubt. Rate of halogenation, speed of halogenation is directly proportional to stability of free radicals. Stability of free radicals. Now, which free radical is more stable? Tertiary free radical or secondary free radical or primary free radical? Already explained that one, isn't it? Primary carbocations stability, carbon ions stability, free radicals stability already given. So here free radicals, because halogenation takes place by free radicals. So which free radical is more stable? Greater the stability of free radical, greater is the speed of the reaction. Suppose what you call this is, so this is what you call primary free radical. Means primary, if it loses this hydrogen, CH3 this one actually, isn't it? If it loses this H plus, it forms such type of free radical. Means it is primary free radical. Primary free radical. Okay. Suppose this one, this carbon atom is secondary carbon because it is attached with 2 different carbons. This contains CH2, 1H. ఇలా separate రాసాం ఎందుకంటే అది separate అవుతుంది కాబట్టి. Actually you can write CH3, CH2, CH3. Okay, if it loses this carbon by free radical mechanism, secondary free radical is formed. This is secondary carbon, secondary free radical. This is tertiary free radical from this compound. This is allylic carbon. Do you know allylic carbon? Allylic carbon means sp3 carbon which is attached to sp2 carbon. sp2 కార్బన్ పక్కనే ఉన్నటువంటిది is called sp3 carbon. That is called allylic carbon. Those hydrogens are called allylic hydrogens. Allylic hydrogens. Okay. The carbon atom which is attached to sp2 hybridized carbon. sp2 hybridized carbon. That should be sp3. sp3. All single bonds. Okay. This is sp2 carbon. This is sp3. This is allylic carbon. This is allylic carbon. Allylic carbon. This carbon atom is called allylic carbon. The hydrogens which are attached with allylic carbon are called allylic hydrogen atoms. So if it loses that allylic hydrogen, then forms this free radical. Allylic free radical. Benzylic carbon, this one. What is benzylic carbon? The carbon atom which is bonded with benzene ring. Benzene ring ki bind ayi undi. Phenyl group lekapothe. Pakkane unnadi. Deeniki aanukoni unna carbon. This carbon is called benzylic carbon. The hydrogens which are present at benzyl carbon are called benzyl hydrogens. 3 hydrogens, of which if one loses by free radical mechanism, benzyl free radical is formed. Benzyl free radical is formed. Of which free radical is more stable? Which is more stable means మనం ఇంతకు ముందు నేర్చుకున్నది ప్రైమరీ సెకండరీ టెర్షరీనే కదా. సో టెర్షరీ ఈజ్ మోర్ స్టేబుల్ దెన్ సెకండరీ ఈజ్ మోర్ స్టేబుల్ దెన్ ప్రైమరీ ఈజ్ మోర్ స్టేబుల్ దెన్ మిథైల్ ఫ్రీ రాడికల్ కదా. మిథైల్ ఫ్రీ రాడికల్. ఇప్పుడు హియర్ దిస్ ఈజ్ allylic carbon is more stable free radical than what you call benzylic free radical is more stable than allylic free radical. So this is the order. So which hydrogen easily replaced? Which hydrogen? This hydrogen or this one? ikkadunna hydrogena, ee hydrogena, either this one or this one. Which hydrogen replaced by chlorine or halogen atom easily? This one, benzylic. Why? Benzyl free radical is more stable. If it loses one hydrogen as free radical, benzyl free radical is formed. Benzyl free radical is stable. That is why it can lose one hydrogen and replaced by chlorine atom. ఇది more stable. కాబట్టి ఇది తొందరగా రీప్లేస్ అవుతుంది అక్కడిది. ఓకే, లైక్ దట్. సో దిస్ ఈస్ వెరీ ఇంపార్టెంట్ వన్. So primary, secondary, tertiary, allylic benzene, increasing rate of reaction towards X2. Increasing rate. Rate is directly proportional to stability. Rate is directly proportional to stability of free radical. Rate means speed of reaction is directly proportional to stability. Stability of free radical. Okay, completed. Now see, look at the board. To avoid the polyhalogen చెప్పాను కదా. If excess తీసుకున్నట్లయితే monochloro. If excess of halogen, if excess of chlorine is taken, carbon tetrachloride is formed. 4th step వరకు జరిగిపోతుంది. ఈ 4 steps రాసాం ఆల్రెడీ మనం కదా. ఆల్రెడీ ఓవర్ దట్ వన్. నౌ హియర్ సమ్ ఇంపార్టెంట్ పాయింట్స్. విత్ ఫ్లోరిన్ రియాక్షన్ ఈస్ ఎక్స్ప్లోజివ్. దట్ ఈస్ వై ఫ్లోరినేషన్ ఈస్ నాట్ takes place. Fluorination is explosive in nature. That should be carried out in the presence of inert gas, nitrogen. To avoid the explosion, చుట్టూ ఏముండాలి? నైట్రోజన్ గ్యాస్, ఇనర్ట్ గ్యాస్. It does not react easily. Nitrogen is less reactive. Why? Nitrogen behaves like inert gases, helium, neon, argon, krypton, xenon. Why? Yes, due to the presence of triple bond in between two atoms. To break these atoms, to break these bonds, more amount of energy is required. Between atoms and molecules which involved in bonding, atoms involved in bonding, molecules directly do not involved in bonding. Molecule should breaks down first into atoms, nitrogen atoms. Then only those atoms involved in bonding. Okay. So nitrogen is nitrogen behaves like inert gas. So fluorination చేయాల్సి వస్తే సపోజ్ CH4 ప్లస్ F2తో రియాక్ట్ అవ్వాలి అని అంటే ఇన్ ది ప్రెసెన్స్ ఆఫ్ నైట్రోజన్ గ్యాస్ కూడా ఉంచి దీంట్లో చేస్తాం. అంటే నైట్రోజన్ గ్యాస్ ఉంచితే ఏమవుతుంది, డైల్యూట్ అయిపోతుంది ఫ్లోరిన్, మాలిక్యూల్స్ తగ్గిపోతాయి, నైట్రోజన్ ఎక్కువ పంపించేస్తాం, అక్కడక్కడ ఉంటాయి ఫ్లోరిన్, అప్పుడు స్లోగా జరుగుతుంది. ఫ్లోరిన్ ఒకటే డైరెక్ట్గా ఇచ్చేసామనుకో, బాగా అవైలబిలిటీ బాగా ఇచ్చామనుకో, ఎక్స్ప్లోడ్ అయిపోతుంది. సో దట్ ఈస్ వై ఇట్ ఈస్ క్యారీడ్ అవుట్ ఇన్ ది ప్రెసెన్స్ ఆఫ్ ఇనర్ట్ గ్యాస్ నైట్రోజన్. ఓకే, అలాగే తర్వాత ఏముంది, బ్రోమిన్ కదా. ఫస్ట్ మోస్ట్ రియాక్టివ్ ఎలిమెంట్ ఈజ్ డాష్ ఫ్లోరిన్, క్లోరిన్, బ్రోమిన్, అయోడిన్. ఫ్లోరిన్ రియాక్టివిటీ మోర్ అన్నాం కదా, తర్వాత క్లోరిన్, తర్వాత బ్రోమిన్, తర్వాత అయోడిన్. ఇజంట్ ఇట్? ఫ్లోరిన్ ఈజ్ explosive reaction with fluorine, explosive. మరి బ్రోమిన్, క్లోరిన్ ఇన్ ది ప్రెసెన్స్ ఆఫ్ సన్లైట్. మీథేన్ ప్లస్ క్లోరిన్ ఇన్ ది ప్రెసెన్స్ ఆఫ్ సన్లైట్, ఇందాక చూసాం కదా మనం, HNU. బట్ bromination takes place in the presence of sunlight and heat because it is less reactive. But for iodination, reaction takes place in the presence of heat and in the presence of catalyst. Okay, that indicates dash property, reactivity of halogens. Fluorine more reactive ani, ఇది less reactive కాబట్టి catalyst కూడా కావాలి. Okay, like that. So now see here, iodination. See here, bromine is less reactive than chlorine, so generally requires high temperature. Okay, అది చెప్పేసాం ఇక్కడ, high temperature, sunlight తో పాటు. అలాగే iodination is a reversible process. అంటే ఇప్పుడు చూడు ఇక్కడ, సపోజ్ iodination is a reversible reaction. అంటే CH4 plus I2 ఇచ్చారు, gives rise to CH3I plus HI. అవునా? Again this HI reacts with CH3I, again forms methane and iodine. Reverse reaction కూడా జరుగుతుంది, possibility is there. So ఈ HIని రిమూవ్ చేసామనుకో, when it is removed from the vessel, only forward reaction takes place according to Leach-Hartlier principle. Do you know Leach-Hartlier principle? Leach-Hartlier's principle. If reactants are added, ఇవి reactants ఇక్కడ, reactants యాడ్ చేస్తే forward reaction takes place. Products యాడ్ చేసావు, if products are added, backward reaction takes place. If reactants are removed from time to time, forward reaction takes place. So here one of the product is removed, at that time also forward reaction. Why? Because that product is not present here. If that is present, then only that reacts with this compound and finally forms these two reactants. అది తీసేసావు HI. అది తీసేయడం కోసం ఏం చేస్తాము, పవర్ఫుల్ ఆక్సిడైజింగ్ ఏజెంట్ లైక్ what you call HNO3, HiO3 are used. That HiO3 or HNO3 converts this HI into again iodine, means product form అవుతుంది. So forward reaction జరుగుతుంది. So HiO3 converts formed HI into iodine, that means reactant. So always forward reaction takes place instead of backward reaction. Understand? Those are the important points. Iodination is carried out in the presence of dash powerful oxidizing agents like HNO3 and HiO3. Why? To avoid the backward reaction. So HiO3 and HNO3 converts HI into dash iodine. Okay, like that. Bromination takes place in the presence of dash, heat, high temperature, like that. So that is about halogenation. Okay, halogenation. Now, so that is not necessary, etc. Sorry, tomorrow I will continue next part. Okay, part 3. Next, continue చేద్దాం. That is about today's class. Okay, students, all of you like my channel and subscribe, share to your friends. Okay, thank you. Right, bye. Meet you again.